Good morning, everyone. Myself, B. Kashinath, working as Senior Lecturer in Electronics and Communication Engineering, presently working at Government Polytechnic, Sangareddy, and presently I am going to teach the subject Electronic Measuring Instrument, which is in third year, fifth semester, and the subject code is 18EC504, and it comes under the elective subject, and it is the first option for the elective. So 18EC 504EA, and it is C18 curriculum, so 18 is mentioned. And the so yesterday we have completed the that is third chapter in EMI subject, that is digital instruments. We have covered the what are the digital instruments and advantages of the digital instruments, different types of digital voltmeters and working of digital voltmeters, and digital frequency meter working and specification of digital frequency meters. And we have discussed then accuracy specifications of the digital frequency meter, and finally we have discussed about the uh, detailed explanation of the digital LCR meter working and its specifications and its applications. And we have concluded this third chapter of digital instruments. uh, so we have already completed the fourth chapter, that is signal generators. Today we are going to discuss about the fifth chapter, that is the test instruments. Why I am not covering the first and second chapter means somebody will cover the first and second chapter doing this online courses, so that's why I have started from fourth chapter, then shifted to third chapter. Presently we are dealing with the fifth chapter, so that is the test instruments. So in that one, subtopic is factor meter or Q meter, we are simply calling it as Q meter. So before going to the subtopic of quality factor meter, Q meter, what are the different types of test instruments that are available to us? So that will be on completion of the class, you will be knowing about the what are the different types of test instruments. And before going to the quality factor actually depends on the resonance, so that is of course series resonance. So we have to know about the basic concepts of the resonance and quality factor of the coils and capacitors. So then finally we are going for the construction and working of the quality factor meter or Q meter simply. So what are the test instruments means? Testing instruments play an important role in all the fields of the electronics industry for testing the all types of prototypes of instruments that are available. So we have to test the whether they are working or not. For that we are using this test instruments. So the various test instruments that are available to us are Q meter. So Q meter is for measuring the quality factor of a unknown coil or capacitor. We are using the Q meter. And distortion factor meter, so anyway I am going just briefly, but in detail we will discuss each of this test instrument in this chapter again. So distortion factor meter is used to measure the total harmonic distortion of the instrument. And the digital IC tester, which is used for testing the IC whether it is working or not by using this digital IC tester. And you will be having the logic analyzer. Logic analyzer is an instrument which is used to test the microprocessors. Means we are like our CPU, is it working fine or not, we will check by using this logic analyzer. And next one is spectrum analyzer. Spectrum analyzer is an alternative to the CRO, as CRO will have x and y axis. On the y axis you will be having the amplitude, and the x axis you will be having the time period, whereas in spectrum analyzer we will be having the on y axis amplitude, and x axis we will be having the frequency. So the frequency and amplitude, variation of the amplitude with respect to frequency, that we are drawing on a plot. So that type of plots will be used in various applications like your amplitude and frequency modulation, phase modulations. So for measuring the frequency characteristics of all types of radars and satellites, so that will be useful in your spectrum analyzer. So it will calculate the frequency dependence of amplitude of the waveform. So finally you will be having the XY recorder and XY plotters. So this will be XY recorder is analog, whereas XY plotter is a digital instrument which will plot the two-dimensional data. So on x-axis you will be having one variable data, on one y-axis you will be having the one variable data. Like that you can draw the stress and strain characteristics or digital plotting of any useful data. Means you will be having the on xy plotter of on x direction you will be having one servo motor, like a servo motor, tacho motor. Like that you can have different types of by using this plotters and recorders. Means you can plot the speed and torque characteristics of the motors, power supply regulation characteristics, and plotting the stress and strain characteristics, hysteresis curves. Like that we can plot by using these recorders, and by graphical interpretation of this whatever we are doing in the recorders, so, that will be provided in graphical interpretation by this xy plotters. So that is whatever the analog on paper what we are doing, that will be printed on a computer screen, that is will be by the plotters, whereas in recorders you will be on paper that you are doing. So these are the different types of test instruments that are available uh, uh, in our syllabus. So we will be having the first one is uh, so Q meter, that we are going to discuss today. Distortion factor meter to measure the total harmonic distortion, and digital IC tester to measure the IC whether it is working or not. Logic analyzer to measure or to check the condition of the microprocessors signals, whether it is for CPU is it working properly or not. And spectrum analyzer, so it is alternate to the CRO. We will be having the on the x-axis you will be having the frequency, on the y-axis you will be having the amplitude, that is the uh, amplitude response with respect to the frequency change, so that you can measure different AM and FM or PM, like that modulations. And XY recorder and plotter for checking the different type of speed and torque characteristics of the motors, power supply regulation characteristics, plotting stress and strain characteristics. And you can plot also this diodes and transistors characteristics. And you will be having the plotters for graphical representation of whatever the plotting that is done by the recorders. So these are the various test instruments that are available, that are there in our syllabus in the test instruments. So we have to discuss about the first Q meter, then total distortion factor meter, digital IC tester, and you will be having the logic analyzer, spectrum analyzer, XY recorder, and plotter. So one more is there actually, but it is not included in C18 syllabus. That is also one of the versatile instrument, that is digital multimeter, which is used to check the all types of voltage, current, resistance, and HFE of a transistor, but is not included in our syllabus, which I am not going to discuss. That is also a good test instrument, but but it is not included in our syllabus. That is digital multimeter, which is used to measure the amplitude and not which is used to measure the current, that is current as voltage and HFE and resistance of a different instruments, but not included in your C18 syllabus. So these are the different test instruments that are available in our syllabus. So today's topic is Q meter. So what is Q meter, how it is going to use, we will discuss today. So why Q meter is required to Q meter is actually we are going to measure the electrical properties, to measure the electrical properties of the coils and capacitors at radio frequencies. So why Q meter is required? It is used to measure the electrical properties of the coil and capacitors. So it is designed for the measurement of the uh, Q factor. So Q meter is used to design for the measurement of the Q factor, that is quality factor of the coil, as well as for the measurement of electrical properties of the coils and capacitors. So you can also measure the quality factor of the series RLC circuits, where this Q meter is based on the principle of series resonance. So you can have the at series resonance, the voltage across the capacitor is equal to q times the supply voltage. That is, you can write it as q equal to vc by v. That is, or you can write voltage across the capacitor will be q, whatever the voltage that is applied into your q factor. So if the voltage applied across the circuit is kept constant, that is, whatever the voltage that is applied across the circuit is kept constant, then the voltmeter connected across the capacitor can be calibrated to indicate q directly. So whatever the value comes on the vc will be equal to directly indicates the quality factor into v. So if you are measuring, if you are kept the voltage v constant, then whatever the output, that is, whatever the voltage across the capacitor at the output, that will be uh, directly gives the quality factor. So I that means vc equal to q into v. So v is kept constant, then vc equal to q into v. So that is, whatever the measured voltage across the capacitor is directly, you can measure the quality factor also. So this q meter is used to measure the electrical properties of the coils and capacitors at radio frequencies. Like it is used for measuring the quality factor of RLC circuit. It is used for measuring the inductance as well as capacitance. You can measure the inductance and capacitance, and you can also measure the mutual inductance, and you can also measure the effective resistance of the inductor. So an inductor, which will not be ideal inductor, it will be combination of resistor and inductor. So you can also measure the effective resistance of the inductor also by using this q meter. So this q meter, how it will look like, and it is based on the principle of the series resonance. So q meter works on the principle of the series resonance. So at series resonance, the voltage across the capacitor or inductor is equal to the q times the supply voltage. Based on that principle, it will work. So vc equal q times v, or vl equal to q times the v. So we have to keep the voltage, supply voltage constant, then whatever the voltage that is presented across the capacitor will be directly indicates the your that is, the voltage across the capacitor can be calibrated to indicate your q directly. So q meter is based on which resonance? It measure based on the series resonance circuits. So what is resonance? Resonance is a condition that we have already discussed in the network theory in the second year. So it is a condition in the series RLC circuit where the your capacitive and inductive reactances are equal. So the resulting in a total impedance will be equal to purely resistive. So because why? Because the capacitive and inductive reactances are equal, means they are cancelled out. So your effective impedance will be only pure resistance. So this is that principle is involved in your measurement of quality factors. So this is the series resonance condition. So, and the quality factor of a series RLC circuit provides a basic definition of quality factor, that will be given by the 2 pi into maximum energy stored at your f naught, or you can also call it angular frequency w naught, by energy dissipated per cycle. So 2 pi ws by wd. So quality factor equal to 2 pi into maximum energy stored divided by energy dissipated per cycle. So this is the basic definition of the quality factor. So you can write it down, the definition. If it is asked for 1 mark, you can write this definition. So it will be equal to 2 pi into maximum energy stored at omega naught by energy dissipated per cycle. So it is the definition of quality factor. So Q factor of inductor, so it is the ratio of inductive reactance to the resistance at the operating frequencies. So operating frequency is your resonating frequency, so it is the ratio of inductive reactance to the resistance. So it is a dimensionless parameter. Similarly, you will be having the Q factor for the capacitor also. It is the ratio of your capacitive reactance to the resistance at the resonant frequency. So Q factor of an inductor will be ratio of inductive reactance to the resistance, whereas in case of Q factor of capacitor will be ratio of capacitive reactance to the resistance. Both are dimensionless parameters at resonant frequency. So if you are having a coil having uh, inductance of Ls and series resistance of Rs, then Q factor of this RL series equivalent will be your inductive reactance Xs by Rs resistance. So 2 pi F Xs will be omega L, 2 pi F Ls by Rs. So ideally your this 2 pi F Ls will be greater than your Rs, we get large values of Q. So ideally the internal resistance of the coil will be less, so you will get the large value of Q. Similarly, you will be having the RC circuit also. It will be if you are having CP, RP, then XP by RP. So where your XP will be 1 by 2 pi FCP. So your Q will be 1 by 2 pi FCP RP. It will be 1 by 2 pi FCP by R, CP into RP. Why? Because XP will be equal to 1 by 2 pi F into CP. So and you will be having one more factor, that is dissipation factor. Dissipation factor, as we have already discussed in the digital instruments, that is in digital LCR meter, dissipation factor is inverse of your quality factor. So you will be having D equal to 1 by Q. So you can measure the dissipation factor also of the capacitors by measuring the quality factor. So a pure capacitor has high dielectric resistance, so hence low leakage. Then you will be having the power dissipation will be ideally it will be 0. Similarly, if you are having the lossy capacitor, so you will not get the pure capacitor all the time. So in practical you are getting the lossy capacitor which is having the low dielectric resistance, hence it will be having the high leakage, so you will be having the high dissipated power. So like that. So quality factor, it will denotes the efficiency of the coils and capacitors that are best evaluated using the Q value that we have already stated. That is quality factor or Q meter is a test instrument designed for the measurement of the quality factor of the coils as well as for the measurement of electrical properties of a coils and capacitors. So Q meter is a test instrument designed for the measurement of Q factor of the coils and capacitors, that is the electrical properties of the coils and capacitors. So as it is based on the series resonance, these are the calculations that we have already known in the network theorem. So again we are seeing, so you will be having the series RLC circuit applied with the Vm at the rate some angle of voltage. Then you will be having the transfer function h of omega will be v of vs of omega y of omega. You will be having r plus j omega l plus 1 by j omega c. So where series resonance condition, the inductive reactance will be equal to capacitive reactance. So we are taking the common of J plus J omega L minus 1 by omega C. Resonance occurs when the impedance is purely resistive, so the imaginary part has to be will become equal to 0. So by substituting that, omega L minus 1 by omega C will be equal to 0. That one we are calling it as resonant frequency. So substitute omega with omega naught L. So omega naught L will be equal to 1 by omega naught C. Finally you are getting omega naught equal to 1 by root LC, or F naught will be 1 by 2 pi root LC. So this you have already studied in the network analysis. So based on that, Q meter is based on this series resonance. In the series resonance equivalence, the voltage across the inductor or capacitor, voltage across the inductor, if you are taking, so that will be equal to Vm by R into omega naught L. So where your omega naught L by R, that is XL by R, is equal to Q. So you will be having whatever the voltage across the inductor will be quality factor times the applied voltage, quality times into applied voltage. Similarly the voltage across the capacitor will be Vm by R. So here XC will be equal to 1 by omega naught C. So similarly again 1 by omega naught Cr will be equal to your quality factor as per the definition. So it will be again Q times the Vm. So as Q equal to omega naught L by R, or 1 by omega naught Cr, that we have already studied in case of the network theory. So by this series resonance equation we may have the uh, this in equations of voltage across the inductor will be quality times quality factor into Vm. Similarly voltage across the capacitor will be equal to quality factor times the applied voltage Vm by these equations. So at resonance the impedance is purely resistive, the voltage and current are in phase, the transfer function will be h of omega will be minimum. This is the actual measurements, how we are taking the Q meter based on the whatever the series resonance we have discussed earlier. So this is the circuit diagram of the Q meter. You can draw this diagram. We have to explain this diagram so that we can measure how we can measure the actual Q. You can note down, you can draw this diagram. So this is the practical Q meter. So in this one we will be having the uh, first block is the wide range oscillator, with a frequency range from 50 hertz to 50 kilohertz to 50 megahertz. So it is generating the frequency in the range of radio frequency. A wide range oscillator with a frequency range from 50 kilohertz to 50 megahertz is used as a power supply to the circuit, and the output of the oscillator is uh, shorted by the low value of the shunt resistance. The output of the oscillator is shorted by the low value of the low value resistance called as RSH, and it is usually in the order of 0.02 ohms, 0.02 ohms. So this is the power supply circuit of the your practical Q meter circuit. So you will be having the wide range oscillator with a frequency range from 50 kilohertz to 50 megahertz, which is used as your power supply circuit, and which is having